This time we've got a heated body which is cooling, and the excess of its temperature above that of the surroundings is given by a function of AO e to the minus KT. Seeing it's cooling, the temperature is dropping, so we'll have a negative there. So at time t is equal to 0, A is equal to 0, A is equal to 80, so find A0, do the substitution. So A is 80, T is 0, so A0 would be equal to 80. And this is what a lot of problems will do. Find that constant out front first. The next part we find the value of K, and we'll get some information to do that. So if the temperature of the surroundings is 20 degrees Celsius, body cools to 70 in 10 minutes, what does that mean? So find A would be 50, and T is equal to 10, because the temperature is going down. So temperature after 20 minutes, we substitute it in the 10 and if you find E, 10K is 518, minus 10K would be log of 518, so K would be minus 1/10 log of 518, or that amount there. So just be wary that K is going to be negative because we're dividing by the negative there. But if log of 5/8 is going to be negative, actual whole thing looks negative, but it's actually positive. So when t is equal to 20, we substitute the 1 minus 1/10 of natural log of 8 in, times the time of 20. It's going to give us the 31.25 degrees Celsius. Now, don't use the decimal approximation for K. Use the exact value that we had there for K as well. The time taken to reach 60 means that if it takes time to reach 60, we actually want it at 40 degrees. What's the actual value there? So 80 equal A equal KT, 40 there, which would give us a half. And you see, I've had to change these values that I've gone through. Notice I've just kept the minus K times T there, and the log of a half divided by minus K. Now, minus K is what we've had before, so just be wary of all that. But I'm just keeping it like that because I want to use the exact value, not the decimal approximation. So when I do that, I'm only going to approximate at the end to get 14.75 minutes.